Hello everyone and welcome back. I am Mr. Cobalt and today I'm going to go over Boyle's law. Boyle's law is a law of gases that relates volume and pressure. So the first thing I want you to think about is the relationship. Think about the particles we're talking about. So when we're talking about gases, we're talking about the particles of the gases and their movement. And so think about us having a balloon that has air in it. The particles are moving around, right? And the reason that the balloon is staying inflated, and why doesn't the balloon just kind of deflate or collapse on itself or whatever, it stays together, is because constantly the particles of the air, the gas inside the balloon, are constantly hitting up against the sides of the balloon, and that's what's keeping it out and taut. So if you think of it that way, so remember, if you throw a ball at the wall, when the ball hits the wall, it's pushing on the wall with a certain force, and then it bounces off, and the particles are the same way. So at any one moment you have particles that are hitting up against the side of the balloon, and that's applying a force, and that's what's keeping the balloon inflated. So now keep that in mind. And so now we're thinking about the relationships between volume and pressure of the gas. Okay, so if you have a certain gas in a balloon, right, and you want to relate, and you're thinking about the relationship between the volume of the container and the pressure of the gas. Now, let's say I want to squeeze the balloon, or let's say I decrease the volume of the container, right? So if we go back to the equation we had, pressure is equal to force over area. So remember, surface area, that's related to the volume of the container. So let's say if I have a balloon and I squeeze the balloon, right? So I'm going to make it smaller. So I'm decreasing the volume, but I'm also decreasing the surface area on which the particles are pushing. So if I'm decreasing the surface area, right? So that means that I'm not changing the number of particles. The number of particles stays the same, but if I decrease the space and I decrease the area on which the particles can push on, then at any one moment I'm going to have more particles pushing on a smaller area. So that decrease in the surface area is going to lead to higher pressure. So if you remember, if you think of area as tied to, or surface area tied to volume, decrease the volume, you're going to decrease the surface area, and therefore you're going to increase pressure. So if I squeeze the balloon or I decrease the volume of my container, keeping everything else equal, then I should expect pressure to go up. So volume decreases, pressure goes up. So that is a relationship of an inverse relationship. So if one decreases, the other increases. And so we can represent that in this way. So the pressure of a gas is proportional, right? So this is the proportional sign. Pressure of a gas is proportional to 1 over the volume. So they're inversely proportional. So this is proportionality. If I know the constant, if I can multiply this by a certain constant, then I can make that equal. So that means that pressure would be equal to some constant K over volume. So now if I multiply both sides by volume, right? So the volume cancels out over here. Now I have volume multiplied by pressure is going to be equal to some constant. Okay, with me so far? So I started with the proportionality, that they're inversely proportional. And then if I know a constant that would make them equal, like the pressure is equal to some constant divided by the volume, right? And volume and pressure are still proportional, inversely proportional. Then I solve for K, the constant. So I have the volume times the pressure of a gas, the volume of the gas times the pressure is going to equal some constant. Now, if this is true, if I change the volume, then I need to change the pressure to keep this constant. If it's constant, it shouldn't change. So for example, if I double the volume, right? So if I double the volume, then if I don't do anything to pressure, then if I multiply this, 2 times V times P becomes 2K, right? So I've just changed the constant, which I don't want to do. So if this is constant, then pressure has to behave in a way if I double the volume. If I double the volume, the pressure has to act in a way to cancel that out. And that means it's going to have to divide, or I'm going to have to decrease by a factor of 2 the pressure. So if the volume increases by a factor of 2, then the pressure has to decrease by that same factor to keep this constant. And so that again shows the inverse proportionality of the volume and the pressure. So if the volume and pressure change, right, then if I start with one volume and pressure, right, so if I start with an initial volume and initial pressure, we'll call those P1, V1, P1, right? So, and this is equal to K, right? And let's say I change the volume to some other volume, right? So let's say I change the volume from some P1 to V2. So whatever I change it to, we'll call it V2. That means that this pressure has to change in such a way that I still get K, the constant. So whatever that P is, we'll call it P2. That P2 has to be such that when I multiply my new volume and my new pressure, I should still get K. You with me so far? So if I have one set of volume and pressure such that when you multiply them, it equals K, and I change one volume, I change the volume from one thing to another, then the pressure also has to change from one thing to another in order to keep K the same. When I multiply this, I should get K. If that's the case, then by a rule of logic, if this is equal to K, and if this is equal to K, then by the same rule, by the rule that two things equal to the same thing are equal to each other, then that means that V1 P1 equals V2 P2. And this is Boyle's law. So Boyle's law basically says that if I know the volume and pressure that I start with, then whatever change in volume and pressure I make, those volume and pressure in the end, or whatever the result is, should equal what I started with. What do I call it? So the multiplication of volume and pressure that I start with should equal the multiplication of the volume and pressure I end up with. And that's called Boyle's law. And so I can solve this, and this assumes, by the way, that everything else stays the same, that everything else is constant. You're not changing the amount of gas, you're not changing the temperature, things like that. So you're not changing anything except for volume and pressure. Otherwise, Boyle's law won't apply. So that's Boyle's law. So if you run into a problem where they talk about the changing in volume and the changing in pressure, and they don't mention anything else, or they tell you that everything else is constant, then you can use this equation to help you solve for the missing part. So a lot of times they'll give you initial volume, initial pressure, and then they'll tell you something like, oh, and by the way, the volume changed from this to that. And they'll ask, well, what's the new pressure? So you can just use this to solve that problem. I hope this is helpful. This is Boyle's law. I hope you understood like where we got Boyle's law, and it all starts from understanding what's going on at the molecular level. Again, pressure, if you change the volume, then pressure is going to change as well. So you could also think about in terms of what happens if I increase, say, the force, right? Or say the pressure, right? So if I increase the pressure in my balloon, then what I expect is if the pressure inside the balloon for the gas increases, then I would expect the balloon to expand, and so the balloon is going to get bigger. But here, if you're thinking about applying pressure, right? So if the balloon gets bigger, right? So if I increase the size of the balloon, then the pressure on the inside is going to decrease because I'm increasing the size of the area that the particles are pushing on. So as the balloon gets larger, the surface area gets larger, and then less and less particles are beginning to push on the balloon at any one moment because there's more surface area to push on, and you still have the same number of particles before. So less particles are going to be pushing on the surface area compared to how much surface area there is, so less pressure. Okay, so I hope that's clear, and if you like this video, share it with your friends, make a comment in the comment section, subscribe to the channel, and make sure you hit the notification bell so that way you can be notified by any other new videos I come out with. Thanks for joining me, and I'll see you next time.